See, now the topic is what are the different kinds of excipients can be used in parental dosage form. See, this is the basic structure of the parental dosage form. See, the parental product. See, the parental product must be sterile, pyrogen free. Next one is clear. It should be clear liquid. Next one is stable, free from the particulate matter. Free from the particulate matter. So this is about the primary requirement for the parental dosage form. See, when we have taken this parental basic structure, the first and foremost thing is vehicle. See, the vehicle nothing but water. Generally, we will prefer the water. See, this water pH can be maintained with the help of buffers. See, why we need to add the buffers in the parental dosage form? Nothing but see, in order to maintain the suitable pH for the drug solubility and stability. See, buffers is used to maintain the optimum pH. That optimum pH is responsible for the drug solubility and stability of the drug. Next one is the vehicle that contain vehicle that contains ions. See, these ions can be used as a tonicity adjusters. Next one is vehicle also contains pyrogen, nothing but endotoxins or exotoxins. How can we remove this pyrogen? Nothing but by depyrogenation process. The same vehicle also contains microorganism. How can we eliminate that microorganism from the vehicle? Means by sterilization or by adding the preservatives. Next one is drug. First one is vehicle, second one is drug. See, this drug that is surrounded with the co-solvent. A drug is surrounded with the co-solvent. Co-solvent also we can call it a solubilizing agent. See, for what purpose we are using this co-solvent? Nothing but if any drug that is having poor water solubility, any drug that is having poor water solubility, that water solubility of drug can be increased with the help of co-solvents or solubilizing agents. Next, this entire parental formulation can be packed into the glass container. This is a glass container. We can pack this entire container into the glass containers. Then that glass that is made up with alkali metals. Glass is made up with alkali metals. Hence, this alkali metal that will leach into the means enter from the glass into the formulation. Once it will enters into the formulation, this is responsible for the oxidation of the drugs. Metals responsible for the oxidation of drugs. So hence these metals can be trapped with the help of chelating agent. That metals can be trapped with the help of chelating agents. Next, this atmospheric oxygen. See, if empty space is there in case of parental dosage form that contains oxygen. That oxygen is responsible for the oxidation of drug molecules. Metals responsible for the oxidation of drug molecule. Oxygen also responsible for the oxidation of drug molecules. Hence, in order to prevent oxidation with the help of oxygen molecule by using the antioxidants. So, so parental dosage form it contains antioxidants, chelating agent, tonicity adjusters, and next one is buffers and co-solvents and preservatives. So here, chelating agent. So chelating agent that can be added in order to trap the metals like copper, iron, and zinc. All these metals responsible for the oxidative degradation of drug. So it is the example of chelating agent, nothing but disodium EDTA. Next one is vehicles. See, people know mainly we will use water as a vehicle. Some of the time we can use vegetable oils such as corn oil, sesame oil, and cottonseed oil or peanut oil. See, these oily vehicles especially used in case of intramuscular route of administration. And some of the times also we can use the synthetic vehicles like ethyl oleate, isopropyl myristate, benzyl benzoate. Next one is the vehicle also contains tonicity modifiers, nothing but ions. Ions will act as a tonicity modifiers. Nothing but we need to adjust the tonicity of Tonicity of parental solutions. What are the tonicity adjusters? Electrolytes like sodium chloride. Under the non-electrolytes, glucose, mannitol, glycerin, and sorbitol. Next one is antioxidant. We people know in order to trap the oxygen molecule that is responsible for. Hence, what are the kind of antioxidant we can use means salts of sulfur dioxide. Salts of sulfur dioxide, including bisulfite, metasulfite, sulfite, are the most common antioxidant used in aqueous parentals, means water-based vehicle parental dosage forms. Next one is we know co-solvents. Co-solvent to increase the solubility of drugs in water. What are those co-solvent? Glycerin, polyethylene glycol, propylene glycol, ethanol, dimethyl acetamide. Next one is preservatives. See, preservatives can be used in multiple dose vials. This can be used in vials but not in ampoules because in vials we can take the drug for many times. So while we are inserting the needle into the vials, then there is a chance of contamination. Hence, in order to avoid that contamination, we can use preservatives in multiple dose vials. That is in case of vials, but not in the ampoules. What are those preservatives? Nothing but phenolics, phenol, cresol, and chlorocresol. Next one is parabens, methyl paraben, propyl paraben. Next one is ammonium. Next one is quaternary ammonium compound, that is benzyl chloride. Also acts as a preservatives. Next one is we need to know about some basic thing here oxidation. See oxidation nothing but see this is a carbon CH4 carbon. Next one is if we have added one oxygen, here also oxygen, here two oxygen, here also two oxygen. See from here this is a carbon is reduced carbon, here the carbon is oxidized. Nothing but oxidation can be increased from first to fourth one. Next one is see the oxygen molecule. O2 molecule is electron deficient. See if it will takes one electron, it will takes one electron like this. See it will takes one electron again becomes a oxygen as a diradical. Next again still it will takes another electron. Now that is here. See oxygen it will takes the electron. It has the capacity to take two electrons. Hence oxygen is electron deficient. Next one is under the oxidation, it is a chain reaction, nothing but chain initiation, chain propagation, chain termination. See, initiation can be done with the help of three initiators. One is oxygen. See, the initiator is oxygen. Next one is metals. Next one is UV light. All these three are acts as a chain initiators. See, this oxygen will make this hydrogen. Take the hydrogen, then only one electron present on radical means alkyl group. Then alkyl group will become radical here, free radical. Next, this metal that will take electron, one of the electron from this aromatic oxide. Then what will happen is it will become plus two. Then one of the free electron will be there on aryl group. Next one is UV light. UV light that will take responsible for one electron can be taken up by OH group. Another electron can be taken up by aromatic group. Hence, it is acts as a chain initiator. Once the chain is initiated, we people will get what we will get radicals. See here radicals we will get. Once we will get the radical, that radical again combined with oxygen atom, O2 atom, then what will happen is formation of alkoxide, hydroxide radical, formation of peroxide radical here, not hydroxide, formation of peroxide radical. Again, this peroxide radical that will be interact with the another drug molecule. Again, that another drug molecule will become free radical. Like that, this propagation nothing but there is a continuous synthesis of radicals. See here we will get one radical, another radical. Like that, there is a continuous synthesis of free radicals in case of propagation step. In the initiation step, just synthesis of radicals. Propagation nothing but number of free radicals will get increased. In the chain termination reaction, two free radicals will combine and it will become get neutralized. It will become neutralized. So now we are using the antioxidant, different kind of antioxidant. See, antioxidants, auto-oxidation. See, if oxidation initiated by oxygen atom, we can call it auto-oxidation that can be inhibited by the antioxidants. Antioxidant that will inhibit the auto-oxidations. Chelating agent we are using, chelating agent that can inhibit the metal catalyzed oxidations. Next one is if you want to prevent the light catalyzed oxidation by storing this drug molecule into the ambered colored glass. Ambered colored glass. Next one is in the chain propagation step, there is no antioxidants will be there. But in the termination reaction, see the termination reaction, nothing but if it is a free radical, here on blocking agent, this here also on blocking agent, this will react with this one, and the chain the chain reaction can be get stopped. The chain reaction can be get stopped with the help of blocking agents. That is in the that will blocking agents will act in the termination step. So what are those different antioxidants? See, preferentially oxidized compounds or oxygen scavengers. Nothing but this will prevent the auto oxidations. What are those one means? Sodium bisulfite, sodium metasulfite, sodium sulfite, sodium thiosulfite, and ascorbic acid. All are water soluble. Hence, we can use in water aqueous solutions. Hence, can be used in aqueous solutions. Next one is chain terminators. We already discussed chain terminators are blocking agents. See, these blocking agents or chain terminators can be used in oil-based system. What are the examples of chain terminators? Nothing but butylated hydroxyaniazole, that is lipophilic in nature. Butylated hydroxytoluene, that is also lipophilic. Tocopherol, vitamin E. This is also lipophilic. Hence, all this can be used in oil-based system. Next, chelating agent to prevent the metal catalyzed oxidation by using EDTA or citric acid. These are the different antioxidants can be used. So these are the structures of that one. See, sodium sulfite, sodium bisulfite, sodium thiosulfate, sodium metabisulfite. See, all this will sulfur having the capacity to form bond with the oxygen atom. Hence, this sodium sulfite will take another oxygen. So this also will take another oxygen. Reaction is there. Another oxygen it will take. Next, here this will take another oxygen. Like that, by taking the oxygen, it will prevent the oxidations. So this is the basic concept about the sulfide salts of sulfates. Chain terminator, that is BHA, butylated hydroxyaniazole. Butylated nothing but it contains butyl group, hydroxy, and this group, methoxy group, you can call as phenyl, phenyl ethoxy group, you can call as a anisole group. Anisole group. Next one is butylated means four carbon containing butylated one, hydroxy, toluene. Methyl group present on benzene we can call as a toluene. Both are lipophilic hence used in oil-based system. Next one is buffers. So buffers used to increase the solubility and stability of the drug. What are the different buffers? Means acetate buffer. So it contains acetic acid and this is a salt. See, if people have added base, it might see, buffers maintain the constant base. How it will means one is it contains pair of compound. One is acid, another one is salt form. If you have added acid, that will be react with. If you have added base, that will react with acid, then neutralization will be there. If people have added acid, that will react with salt, then acid neutralization will be there. Next, citric acid, sodium citrate. Same, if you have added base, react with acid neutralization. If you have added acid, that will react with salt neutralization. Same thing, phosphate, base that will react with acid neutralization. Acid react with salt form neutralization. Like that, this buffers will act. So this is about the experiment. Different additives can be used in parent or dosage form.